Okay, so we're doing exactly the same thing we did yesterday. All the same questions. The only difference is now we're looking at graphs, right? Yesterday we were looking at equations. X of t, most of the time they gave us x of t. We started with x of t and we had to answer the questions, right? When is speed increasing? When is the particle moving left or right when time is 5? When is the particle at rest? Those types of questions. Well, we're still going to get those types of questions. The only difference is the pieces of information they give us look different. They're not different, they just look different. Okay, so example number 5. Let's look at example number 5 here. Let me take roll real quick and then we'll do it together. Okay, so when you're read number 5, again, underline, circle, highlight, important stuff, what our job is, what we're trying to do. Okay, so we'll know, we'll kind of set out a path of what we're trying to do. Okay, so while I take roll, do that. Okay, so the lag on mine is really bad right now, so don't wait for me to write things down. Listen so you can write them down because it won't show up there for a few seconds. Okay. Um, okay, so particle is moving along the x-axis so that its velocity at time is from 0 to 18. Okay, so now we got a cap. We don't go past 18. Okay. Is given by v of t. That's different. We've never been given v of t. We've always been given x of t. So now we're starting in the middle. We're starting with velocity. Okay. We're not starting with position. So the first derivative of velocity is acceleration. Okay. So to get to acceleration, we don't need to do second derivative if we need to do that at all. Okay. So the graph, this is really a first derivative graph. It's the graph of x prime of t. Okay. It's a first derivative graph. Okay. Like I said, I wrote it 5 seconds ago, but it hasn't shown up yet. My lag is really bad. Okay. So you're going to have to really pay attention. Okay. Okay. So whose graph is shown in the picture below? The inflection points are marked in green. They're marked in green on mine, but they didn't come out green, but they should still be little circles on there. So on yours, there's little circles on the graph. Looks like at x equals 5, x equals 7, x equals 10, and that's it. Okay. The last one is not one of the green circles. It's the end. It's the end of the interval. Okay. Okay. So those are inflection points. So what does that mean? They're inflection points. If they're identifying inflection points, what does that mean? Why are they inflection points? Why are those guys inflection points? Yes. Yeah, they're points where the concavity changes, right? Um, you can see that it's going from concave up, holding water, to concave down, right there. That's where it changes. That's where it changes again, concave down to concave up, and then concave up, holding water, to spilling water, okay? So the inflection points of the graph are marked with green circles. Find all of the intervals of time when speed is decreasing. So that's what we got to do here. Speed is decreasing. We did this question. I think we did, the last question was speed increasing, but it's the same type of idea. We're going to do the same steps. So how did we know when speed was increasing on the last one? What did we look for? What did we do? We looked at the table, right? The first thing we did was look at the table. That's where your eyes should go immediately. Anytime you're doing any of these problems, unless you've memorized the table, go to the table, okay? Because a lot of times people look at this and they're like, I don't know what I'm doing. Go to the table. That's why I put it there, okay? Find where speed is decreasing, right? Speed was increasing, positive velocity, positive acceleration. Speed was increasing, negative velocity, negative acceleration, right? Okay, that's not what we're looking for here. Now we're looking for speed decreasing, okay? Speed decreasing is slowing down. So we got one here, and we got one here, right? So it looks like when velocity is positive and acceleration is negative. Or when velocity is negative and acceleration is positive, when they have different signs, right? When they have different signs. So we got to go figure out, where is velocity negative, where is it positive? That's the first thing we're going to do, okay? So we're going to mark up our graph. We're only worried about velocity right now. That's all I care about is velocity. Let's do one thing at a time. So I need to figure out where velocity is positive and where it is negative. Okay, here we go. How do I do that? How do I figure out where velocity is positive and where it's negative? Where on this graph, what am I looking for when I say velocity is positive or velocity is negative? What am I looking for? Yeah, you guys. There you go. Yeah, there you go. This is the graph of velocity right there, v of t. This is velocity. So all I'm looking for is where it's above the x-axis and where it's below the x-axis, okay? So I'm going to label that. So on mine, I'm going to say, okay, so this is, okay, so I'm going to color code mine. I'm going to say that velocity is greater than 0. Okay, and I'm going to pick a different color. Let's choose green. Green, I'm going to do below. Now, color coding might seem very elementary. Might seem very like, why am I color coding it in calculus? But trust me, anytime you can visually see things, it's so much easier to do this problem. Okay, especially with graphs, because graphs are all visual. I can't do calculations, right? I can't go back to my calculations. A lot of you are comfortable with these calculations because they're steps, right? I do this, and I do that, and I do this. You can't do that with graphs because there is no calculations to do. So anytime you can make it visible, anytime you can make it visual, it's easy. Okay, so if you don't have color coding, you can like scribble. You can do this. You can like do that for that and leave one. I don't know. There's different ways you can do that for, you know, there's different ways you can color to code it, right? Okay. Okay, so that's where velocity is positive, the velocity is negative. Now I got to do acceleration. Where is acceleration going to be positive and where is it going to be negative? That's my next question. Where and how do I tell? Because I got it. So this is my next step. Where is acceleration going to be positive and where is acceleration going to be negative? That's where I'm going to color code it next. I ran out of colors. Okay, so let's use this color. Okay. How do I know when acceleration's going to be positive? How do I know when acceleration's going to be positive? What's the relationship between the graph here and acceleration? How are they related? What's the relationship between the graph you're looking at and acceleration? Yeah, Ella? Exactly. It's just going to be the derivative graph, right? So I need to find derivatives for this guy here to figure out if acceleration is positive or acceleration is negative. Good. So how do I do that? What are derivatives? How do I find derivatives for the graph I'm looking at? Derivatives are slopes, right? So if a slope is positive, that means it's going to be going uphill, right? Increasing. If derivatives are negative, that means it's going downhill, right? So that's where I'm going to color code it next. I'm going to figure out where it's increasing and where it's decreasing, okay? And those little dots there are going to help me because that's the separation between increasing and decreasing, right? Sometimes they are. Okay, so let me go back. Okay, so increasing first. Well, it's increasing here and stops right there. I think that's where it stops, right here, from increasing here. All right. And then the rest of it is decreasing. The rest of it is decreasing. Okay. So I'm not even going to, you know what, check this. I'm just going to circle it and put decreasing. So from here to about here, is positive. All right. V prime. Again, V prime is the same thing as acceleration. Okay, if I go. Acceleration is the guy with the biggest amount of symbols. X double prime, V prime, or just acceleration. Okay. Everywhere else, it's decreasing. So everywhere else, acceleration is negative. Okay. So let's go back to the table. Which parts are we looking for? Where it's what and what? Speed decreasing means what and what? What does speed decreasing mean? What does speed decreasing mean? What and what? There's two things that have to happen. Actually, two things and two things, right? Two separate situations. What's the first one? Vice versa, right? Opposite signs. Opposite signs. Okay, so let's do positive velocity first. Positive velocity first. Okay, so let's make a little note to ourselves down here what we're doing. so we don't forget it. Okay, so positive velocity and, oops, that's not positive. Positive velocity and negative acceleration. All right. Let's look at that one first. Positive velocity and negative acceleration. Okay, so positive velocity was my blue, right? Was my blue. Negative acceleration is everything outside of my circle here. Everything outside. So I'm looking for blue outside the circle, right? Blue outside the circle. Well, 0 to 1 is one of them, right? 0 to 1. Or, and then the other one I think is from 13 to 16, right? 13 to 16, that's outside. Right? So velocity is positive there, it's in blue, and acceleration is negative. It means it's decreasing, right? So those are two where speed is going to be decreasing. Okay, now let's do the other one. The other one was the opposite, vice versa, right? Velocity is negative and acceleration is positive. Okay, so velocity negative means green. Velocity negative means green on mine. Okay, acceleration positive is in the circle, right? So it's kind of like a Venn diagram. You're looking at where they share, right? So where is it green and in the circle? Where is it green and in the circle? Looks like from 8 to 11. From 8 to 11. Okay. So you would say, so to answer this question, if it was a free response question, you would say speed is decreasing 0 to 1, or 13 to 16, or 8 to 11, or you can move the 8 to 11 in here. Order doesn't matter, but as long as you got those three sections. What's your justification? What's your justification for why you put those three? Why are those three in my intervals to answer the question? Because this is your right here. Exactly. So you could put two things. I like what you, Raj, said better because it's shorter, where velocity and acceleration have different signs. Or you can put because velocity is greater than 0 and acceleration is greater than 0, or velocity is less than 0 and acceleration is less than 0. Mine has more verbiage, more words, more symbols, right? I like the one you, Raj, said better. All right, I like that one better because it says it's what it is. You're just saying the signs are different. The signs are different. Okay, if the signs are different, you're going to have speed decreasing. Okay, because velocity and acceleration have different signs. One more time. I don't want to have to take off points on the next test because justification is off. Okay, because velocity and acceleration have opposite signs or different signs. Okay. Okay. So try this one on your own. This one is speed increasing. Speed increasing. Similar, but not the same. Okay. Try it. Okay, so I color coded mine again. So yellow is velocity positive. Pink purple color is velocity negative. Okay. And then in red, there's two little arrows there. I kind of outlined in red where acceleration is positive because it's increasing. Okay, so everything else is decreasing where acceleration is decreasing. So I looked at my table and I figured out my justification. My justification is going to be when they have the same sign, when acceleration and velocity are both positive or when they're both negative. Okay, so that's the last thing I got to do. I got to figure out where that happens. Okay, so positive, let's do positives first. So positives in the red, outlined in red, positive acceleration and yellow. So I'm looking for red and yellow, red and yellow. So that looks like it's going to be right here. That's one spot. So what is that? 1 to 4. So 1 to 4, or, and also right here, looks like that's 9 to 12. Okay. All right. That's positives. Now negative, negative. So not outlined in red and pink. Not outlined in red and pink. That's right here. 17, 18. Because V of t and A of t have the same sign. Okay? Because they have the same exact sign. Okay? All right, so let's look at the last. I think there's only 2 left. Yes, 2 left. So things kind of change up here. So read it, figure out what's different. What's different than the first 2 graphs we've looked at? Take a look at it, read it. What's different? What's the same? So similarities, differences. What do we notice? Similarities, differences. What do you guys notice? Hmm? Exactly. That's one difference, right? Now we're not looking at velocity graph. We're looking at the position, the original. Okay. So that's important. Definitely important. So let me highlight that. Good. What else? Differences or similarities? Either one's okay. I don't care. Something different, something the same as the last one, because that's going to help us with this question. So everything's the same as the last question. Yeah, Ella? That's what we're trying to find, negative acceleration. We haven't done that yet. We haven't done that. The first 2 were positive, were speed, right? We're speed related. This guy here is negative acceleration. Yeah, negative acceleration. What's another word for negative acceleration that's going to be on my sheet? On my, sorry, my table. How do I know where to look for? Because I don't think I used the term negative acceleration. But what is negative acceleration? Not going to the left. That's velocity. That's velocity is negative. It's going to be second derivative. Yeah, it's going to be second derivative. But what is my, so my sheet, so my the first page you guys have, the table, where does negative acceleration happen? Where does negative acceleration happen? That's my question, I should say. Is it 1 box, 2 box, 3 boxes? Where is negative acceleration on here? What does that mean, negative acceleration? Yes. Yes, when what's below zero. Yep. So acceleration below zero right here. So any of these things here. Any of these things here. So really, this don't matter. It could be positive, it could be zero, it could be negative. I don't really care. Any of these right here. So all we're looking at is when acceleration is less than zero. Okay? So any of these guys here. Okay? So it's not like the last question. The last question was when this is positive and this is negative. So you kind of moved, you're like this or like this, right? This one is not that. It's just this right here. When this thing is zero or less than zero, I should say. Okay? Okay, so let's go back. All right. So go back. Danya, what did you say earlier about this? Right? Because isn't position the first, right? The original. And then they're asking us to find acceleration, negative acceleration. That's the second derivative, right? Of this graph. It's the second derivative of this graph, right? How does that correlate with what we've been doing? It's going to be concave down. Yeah, it's going to be concave down. So really, we're just looking at where is it concave down? Where is this thing concave down? That's essentially what we're doing. Okay, so I'm going to highlight it. Let's see here. Concave down. And luckily, those green dots separate where it's concave up and concave down. So that the green dots are actually going to help us. So it starts. So concave down means spills water, not holds water. Okay? So when I start to the first green dot, that's holding water. Right? That's holding water. That's concave up. That's not what I'm looking for. But from the next green dot to the next green dot, that's spilling water there. So that's going to be one spot. Okay. And then I go from the green dot to the green dot. That's holding water. That's not what I want. And then the next two green dots, that's spilling water. That's what I want. So I'm going to highlight that as well. And then the last part is concave up. That's not what I want. So negative acceleration is this here. So, so we're going to put the intervals. So it looks like it's from 5 to 7 or from 9 to 11. What's my justification here? Why did I choose those areas? Because don't say concave down. That's true, but why is it concave down? Because and what is acceleration? Acceleration is second derivative. That's where the second derivative is negative. Okay? That's where the second derivative is negative. Because x double prime is less than 0. Okay? That one wasn't too bad. We didn't have to do any matching or anything. But again, unless you recognize some of the buzzwords and unless you recognize some of the things, it's very difficult. Okay? That's what I'm trying to show you. The words in this case are more important. The words and what's going on is more important than necessarily anything else. Because if you can understand this stuff, what you're looking for, then you know what you're doing. Okay? Let me change before we go to the last question. Let me change this. Let's say we redid this question, but instead of acceleration or instead of x of t, let's say it was, don't write this down, just look at this, v of t. Let's say the question was exactly the same. All the parts up here were exactly the same, but the graph was v of t. Would my answer be the same? Give you some time to process that. Talk about it with the person closest to you. Talk about it with the person closest to you. Would the answers be the same if that graph was velocity graph instead of, okay? Okay, so would the answers be the same? And if they're not the same, where would I look? Hmm? Nope. Okay, yeah, that's correct. They would not be the same. Where would I look if I wanted negative acceleration? Where the graph was what? What would the graph have to be doing for me to answer if this was the velocity graph? Yes. There you go. Yep, decreasing, negative slope. That's where my answers would be. Okay, so from 10 to 12, from 0 to 4, those would be where. Okay, good. That's the idea. Whatever you're looking at is going to determine what your steps are. So that's huge if you can tell what you're looking at. Okay, all right, last one. Okay, so underline, circle, do the same thing. Give you 30 seconds, a minute to do that. Understand what the problem's asking. Okay, so we got the same graph, x of t, as the last one, right? So we have the position graph. This is the position graph, okay? Inflection points are in green again. Find the intervals when the particle is moving to the right. Moving to the right. What the heck does that mean? Moving to the right. What the heck does that mean, Rome?
It's when velocity is 0 and acceleration is positive.
No, it's even easier than that. Even easier than that, yeah.
It's when velocity is positive.
That's all. That's it right there. Let's go back up to the tables. Oh, I see what you're saying. Roman, were you here? Yeah, right here. That's acceleration. When acceleration is right. So when acceleration is positive. That's all it's saying is when acceleration is positive. When we're looking for movement right or left, we're going to go down here to the motion one. That's where we're going to go here. Okay? So when the object moves right, all that means is velocity is positive. Okay? So we're looking at the graph. Where is velocity going to be positive? Okay? So let's go back down to the graph. Where is velocity? Because v of t is positive. Okay? So I'm looking at the position graph. Let's highlight where it's going to be. So if velocity is positive, what am I looking for? Things that when the graph is doing what? When the graph is going uphill, increasing, where slope is positive. So I'm going to highlight, circle, underline, shade, where it's increasing, and that's it. All right. So my intervals are from 0 to 4. Or was that 7 to 10? Because v of t is positive. Or you can say x prime is positive. Or you can actually write the words velocity is positive. Either of those is good justification. Okay. How would my answer change if this was velocity? So let's ask that question again. How would this change if this was the velocity graph and they were asking for when the particle moves to the right? What would my answer be? How would it change? What would I look for? Those types of questions. Yeah, Hubert? That's it right there, right? You would just look for where is it above 0? Where is it above the x-axis? Where is it below the x-axis? That's it. Okay. What if I did this? And said that's the acceleration graph. Where is velocity going to be positive? How would I do that?
On the positive when it's concave up.
Let's see when it's concave. Yeah, you would look. That's one way you would do it. Yeah, you could do it that way, where it's going to be concave up, right? Because if it's concave up, you could kind of do it that way. Because if something's concave up, or sorry, concave down, right? Because if it's increasing, it's kind of creating that concave down, or right? But it could be creating concave up. So that's kind of, you could do it that way because second derivative, you can use the second derivative to figure out where it's increasing and decreasing. But it's kind of a trick question. I'm not going to make you think about it too hard because this is what we're doing second semester. Second semester this is what we do first semester. First semester, we go down the list, right? Original, first derivative, second derivative, third derivative, fourth derivative, right? We go down, right? Have I ever asked you to go up the list, to go from here to here, here to here? No, I haven't, because that's not derivatives. That's called integration. And that's what we're doing all second semester is integration. But think about it. If you know the steps to go downhill, to go down the list, what do you think the steps are going to be to go up the list? Opposite steps, right? So let me ask you this question. Let's say I had position and I needed to find velocity. What would I do? Find the what? I heard it somewhere. What do I need to find? If I'm here and I need to go here. Even easier than that, I heard it. I heard the word. What would I need to find? What would I need to do? So somebody said it. Somebody whispered it. From position to velocity. So to go from here to here, what would I need to find? The derivative, right? Yeah, the derivative. Someone said it. Whoever said it didn't want to say it louder. Okay, just find the derivative, right? We did that earlier. We did that yesterday, right? So to go down the list, I find derivatives, right? What do you think it is to go up the list? If I find derivatives, what do you think it's called to go up the list? Yeah, what do you think it's called though? You know that the way we go down the list is to find the derivative. It's called the derivative, right? What do you think it's called to go up the list? Find the what? Close. I'll give you a hint. There's two parts to it. One of the words is derivative. Something derivative. There you go. Antiderivative. That's all it's called. The antiderivative to go up, right? So the process we do, integration, is the same process you guys have been doing since September, right? So integration next semester, it's not that bad because your process is the same. It's just going the opposite direction. Okay? So yeah, that's what we're doing. Second semester. This semester we're going to finish derivatives. Next semester, that's why we start with derivatives, because how it's easier to find the antiderivative if you know how to find the derivative. Okay? All right, guys. Okay, so this assignment is posted or will be posted today. So if it's a graph, so half of it is like 1, 2, 3, and 4. The other half is like 5, 6, and 7. If it's a graph and you're analyzing a graph, I don't want to say don't show work, because I mean there's ways you can show work, but I'm not going to grade you on how much work you show, right? Because you're analyzing graphs. So if you're analyzing graphs, I'm not really, see, I hate to say don't show work, because some of you label graphs and some of you have your own process. So you actually do show work. Like this is work right here. See, when students see this, they don't think this is work. It is work. Just because it's not, right? You guys want to pack up? I'll wait. Okay. I'll give you plenty of time. We got 6 minutes. I think you guys can pack up in 6 minutes. Okay. Because this is important, because I get questions like this all the time. And they're good questions. So since I got you guys here and we're done a little early, people think, oh, this is work. You're right. This is work. But so is this. Just because we're not doing calculations doesn't mean it's not work. Okay. So if you have stuff like this that you do for these questions, upload it. Okay. If you don't, that means you're doing it completely 100% in your head. I can't even do that. Right. So I'm not going to grade too bad on that, but I would like you guys to, show at least some work on show your thinking. That's all I want to see. Your thinking on how you got your answer. It's not calculations. I don't expect that, but there's still ways to kind of show work there. Okay. But I'm not going to grade as heavily on that. Okay. Because it's more analysis than anything. Okay. Another thing is, make sure I post the videos that I'm recording right now. They're there for students who are absent, but no one's absent today. Okay. But that doesn't mean don't look at them, because I'm seeing the videos and I'm seeing not a lot of people are watching them. And then people are saying people are struggling. I know it's hard, but because when you go do your assignment, right? It's 5, 6, 7, 8 hours away. Maybe even tomorrow you're going to do this assignment, right? You forget this stuff. You look at your notes and you're like, what? Rewatch the video. Okay. If you understood it today, rewatch it and you'll understand it again. Okay, I encourage you to rewatch those videos. That's what they're there for. They're not only there for absent students, they're there for you guys, because when you sit down and do your assignment and you're having issues with it, rewatch them. Okay, I encourage you guys to do that. That's what they're there for. All right, guys? Okay, now, yep, now you guys can pack up.